So our friend, the discriminant, right, which I will not write, discriminant. It's the triangle, right? We know that that is b squared minus 4ac. Sorry for people, I'm yelling now, raising my voice. B squared minus 4ac. And we know that when the discriminant is greater than 0, why am I hearing chatting? We know that it has two real, distinct. Why is it important that I put the distinct in there? As opposed to real repeated, right? That's why we've got to be specific in your investigation. So two real distinct roots, and graphically, that means it cuts the x-axis twice. Now you should only be writing this down if you weren't here yesterday, or maybe you didn't write it down yesterday and now you wish you want to. When the discriminant equals 0, that's when we have a repeated root, or you could say that is when we have a squared, not a squared root, but a squared factor. So make sure we know the difference between when something is a root and something is a factor. So as an example, this would be e.g. x equals 1 and 1 again. And what does that mean as a factor? That would be x. I love that you said take 1 and not plus 1. Thank you. You just made my week. Otherwise, I would have had a crushing. But my vacuum has been delivered today, the Dyson. I'm very excited. As long as it's still on my doorstep when I return home. $1,000, they're just leaving it on my doorstep. Not too happy about that. Anyway, what does that mean graphically? Just touches, not in an inappropriate way, touches the x-axis. And, Jazz, are you paying attention? Thank you. So, finish this off. When the discriminant is less than 0. Pardon? No real roots. Now, in the olden days, no real roots, what I would be saying, and the specky people out there could, because you'll look at this next semester, but that would actually mean you have two distinct imaginary roots. Right, and what does that mean graphically? Right, totally above or below x-axis. So it does not cut, it does not touch, right? Happy days? All right, so we're going on. We were going on to actually look at problems using the discriminant, okay? Now, I didn't ask you to do this for homework. Should I ask? Who actually finished the exercise? Nobody. That's good. That's good. That's fine. So if you could please turn to page 103. Because the discriminant was old news, but the new skill was a sign diagram and working out when, for what values of k was it going to be positive and when was it going to be negative, okay? So Kazmeister, we watching? You're the Kazmeister. Rock the Casbah. All right, so same things for all of these, and remember we just talked about this. When does it have two real roots? When it's greater than 0, two distinct. When it does two real, it could be greater than or equal to. When it's a repeated, that's when it's equal. When it's no real root, less than. So here we go. Sorry, the zipper's just stuffed on that one. B squared minus 4ac. You're writing this down. Let's go. What's my B value? Morgie Meister wasn't here, probably isn't up to this yet. So you can tell us, Morgs, it's stuff you've already done because we know ax squared plus bx plus c. Correct. And what you'll find is this is going to help you, even if you skipped, we haven't got up to this in the previous chapter, this will actually help. Okay? So our b is the k plus 2. So we're writing that, we're saying k plus 2, it says to square it. I go minus. So I'm getting really annoyed that I can hear chatting while I am. Enough. 4 times my a value. Well, there's just a 1 there. If you really want to look like you're doing extra work, you can say times 1. I'm leaving it out because it has no effect. And what's my c value? 4. Oui? So nothing new, just substituting, and we can do this. We're going to expand k plus 2 squared. I was telling my year 10s earlier that sometimes I have to mark work all by myself because I start yelling. Because one of the things that bugs me and really sends me off is when a year 11 student will expand k plus 2 squared. And what do you think they expand it to be? Yeah, they go, oh, it's k squared plus 4. The other one, what's minus 4 squared? Did you do that? What's minus 4 squared? What do they tell me? They say a minus 16 because calculator said so. No. Negative times a negative is a positive. So please be careful. Right, so you better make yourself a note. So here we go. It's k squared. Remember, you've got the middle term. So if you need to, everyone is different out there, right? If you need to remind yourself of how to expand, then for God's sake, do it. Okay? K squared, you get a 2k plus another 2k. So that's plus 4k plus 4 minus 8. Sweet?
No, not.
Good. Good. Checking that you're paying attention. Who just copied that down? Good boy. Dylan wins the prize. 4 take 16 minus 12. Momentum just takes you there because you see a quadratic, and at this point I'd like to think you see a quadratic, you just want to factorize the sucker. Okay? So we look at it and we go, are there two numbers? That times together gives you 12 minus thereof. But when you add them, you get 4. 6 and 2. So we're going to do this. So k plus 6, k take 2. All right? If this is in the non-calculator section, you take 5 seconds out of your busy life to do a little check expansion. Does it actually work? Okay? If it's in the calculator section of your test, you probably wouldn't even need to factorize. You would just use equation on your calculator. Save yourself a line. Oui? So now we can say, therefore, k equals negative 6 and positive 2. So I would like to say nothing new here. Agreed? Here comes the new bit. Now, Karen, very, very hard. So we better pay attention to this because this will blow your mind. We draw a line. A line. Are we okay with that? Haven't panicked yet? All right, we've got the line. Now here comes the next hard bit. We have to put minus 6 and 2 on the line.
But where?
And I know I'm pushing my luck on a Friday last lesson, but they also have to be in order. So don't put 2 and then minus 6. Please put minus 6. Right? It's a number line. And just when your brain is fried, I keep going and I say, uh-oh, now you have to think and you have to pick a number that's bigger than 2.
3.
Someone just said, what? It's funny. We're playing along. That's good. Right? Pick 10. Morgs, you could pick 100. Right? You could pick 3. It doesn't matter. That was funny. Right? I'm going to go 10. So here's what we do. That was funny, but here we go. We pick a number beyond 2 and we go 10. I'm choosing 10. You can choose whatever number. I go 10 plus 6. You can work it out if you want to, but all I care about is its sign. It's positive. 10 plus 6 is positive. What's 10 take 2? Positive. What happens when you have a plus and a plus? You have a positive answer. Now, here's stressful part number 2. What's a number in between? Jazz has lost the plot. What's a number in between minus 6 and 2?
1.
Yes, 1.
Yeah.
You can choose one.
What about that?
I did have to stop and think. Yes, it's Friday. So I'm choosing 0, but you could choose 1. 0 plus 6, positive. What's 0 take 2? Negative. A positive and a negative times together gives you a minus. What's a number beyond minus 6? Now, you already get the gist and you can probably go, oh, yeah, positive, right? But always double check just in case you've made a whoopsie. It's a good way to check. Hello. Yeah, when do you think it'll go minus minus or plus plus? Yeah, and when would I have both? When I have a squared factor. Ah, see how it's all coming together. You got to have a bit of faith and we get there. George Michael. Okay, so pick a number beyond minus 6. Minus that, I'm going to go minus 10. I love the minus 10. Minus 10 plus 6, that would be negative. Minus 10 take 2 is negative. A negative and negative makes a positive answer. Huzzah. Okay, so if you have the questions in front of you right at the beginning, it said, when did you have real roots? What was it? 2 distinct real roots. So that's, when is this greater than 0? So we want to say when k is less than minus 6 and when k is greater than 2. So we say k less than minus 6, k greater than 2. Okay? B, when did it have just real roots? That is when, and by the way, I've been a bit naughty here, in a test, could you always just add in, oh, I know that that's when it's greater than 0, and then this is when it's greater than or equal to 0. Always write that in, because I will, seriously, that gets you half a mark. If you happen to stuff this up, right, stuff that bit up, I'm still going, oh yeah, they know what the question is about. They've just then stuffed something up later on. God knows what they were thinking. 1, maybe. And so what's the difference here? It's exactly the same as above, except it is less than or equal to, right? Greater than or equal to. And then for C, that was when it had a repeated root. So you would write equal 0. When does it equal 0? When k actually equals minus 6. When k equals 2. And I'm sorry if you're writing and listening, but I've decided this is the only one I'm going to do, and then you can play yourself. When do you have non-real roots? Was that the last bit? No real roots. So that's when the discriminant is less than 0. So this is where you do have to listen. We're talking about this section here. So in between 2 and minus 6, this is mathematical notation. I will not take any fake notation here. We're saying k, it's in between minus 6 and 2, so it's got to be less than 2. And if I'm reading k, it's greater than minus 6, because I'm reading from k outwards, right? Greater than, little. Minus 6 is less than k, but k is greater than minus 6. Capiche? All right. So, expansion we can do. Fully factorise. How are you meant to do that? What do we do every time we look at something to factorise? The absolute first thing we do when everything is on one side, we look for a common factor. So at this one, we will pull out x as a common factor. What you're going to be left with is a quadratic. And so then you do the same skills that you do before. You will either factorise that or you will quad formula. The fact that it says fully factorise, I think you're going to be able to factorize all of them. All right? So again, stuff that we already know. Onwards. Uh-oh. Fully factorized, given that x plus 5 is a factor. This is semi-new. So, watching, we have options here, peeps. These books were written a little bit before your new calculators came to mind. So what they're intending with this question is one of two things. The first thing, if it's a factor, what they're saying is this means it's going to be x plus 5 as a factor. And then you're going to do, x times what gives me x cubed? X squared. Alex, I look up, you're not looking at the board when I'm pointing to it. That's making me angry. Can you tell me what C would have to be here? 5 times what gives me minus 30? Negative 6. Do we know what the middle term is? How do you know it's negative 11? I'm afraid to say you don't know what it is. So that's when we call it BX. Now, back to the textbook. What we did at the start of this term wasn't that this? Isn't that the same thing? Yes? You're equating the coefficients. So you'll go over here and you'll go, okay, I will pick now x squared. And on the left-hand side, the coefficient is 4. On the right-hand side, how do I get x squared? How do I get an x squared? You can get it by x times or 5 times x squared. So you've got b as the coefficient or 5. So what's b got to be? Got to be, got to bang. Got to be, bada bang. B is minus 1. And then you can factorize. I can guarantee you that I could give you one like this where instead of, I just give you this. And I don't even give you that. Do you know why? Because your calculator will tell you. Get your calculator up. Calculator on my desk, Lila. We'll look at. You haven't got one either. All right, so we go into equation. We're going to go polynomial. We're going to go degree 3. And we pop in 1, 4, minus 11, minus 30. 1, 4, minus 11, minus 30. Why did I check that? Now, this one, you can see it actually does it all for you. I will be spending, or I have spent a fair bit of time making sure that when you do that, these two values here will not be pleasant. So it means that you will have to go, I can see one of them is nice, write the factor, then you've got to do the other. Make sense? That's a lot of work for me. Damn calculators. Too smart. So the older calculators for this question wouldn't give you exact. Now they do. So we have to go and change. So with these questions from the textbook, can you practice doing them with and without your collator? Okay? But you can see how it starts repeating. Repeating. So it's not always new work. It's the same thing, just adding one little more tool at your disposal. All right, so that's enough from me. Carry on. Finish the discriminant. Ask any questions in your investigation. Making sure. I want to see somewhere in there where you have discussed and calculated the discriminant. That must be in part C. Even if you didn't investigate a function, a quartic that had a quadratic factor of a discriminant less than 0, when you're talking about the types, do it in there. Oui? And if you really want to make me happy, talk about sum and product in part A.